sample because you're not all of Florence Darlington Tech.
That's right.
You're all of my sample. See the difference?
Mm-hmm.
All right, let's look at the next one.
But I have to think of it like it's all of the people you asked.
Right. But if it's all the people I asked, then it's a survey, because you only asked a group. I know. 49, 34, and 48 students are selected from the sophomore, junior, and senior classes with blah, blah, and blah respectively. Cluster, stratified, random, convenience, or systematic.
Stratified.
Damn, y'all are good. This one usually gets people. If I have a room with sophomores, juniors, and seniors, and there's 496 people in this room, 348 people in this room, and 481 people in this room, I'm gonna pick 49 people in here. I'm gonna pick 34 people in here, and I'm gonna pick 48 people in here. So I am picking a few from each room, therefore, yes, it is stratified. Impressed. Temperatures of 8 different plastic spheres.
I hate this question.
No.
Temperatures, I think, is always supposed to be interval, usually.
So if it's 0 degrees Fahrenheit,
It's something.
it's cold or dead or whatever. So it is going to be interval.
Okay, but one of them questions on here says the max daily temperature on a Kelvin scale, and it called it quantitative, ratio, and continuous. That was the answer. It was number 73. So it really confused me.
I would disagree with that one.
It would be interval, right?
It would be interval.
Because it says the max daily temp. So it wouldn't be 0 maybe? I couldn't-
Okay, no, they're saying, okay, read the question to me again.
I just kind of scribbled down. It said the max daily temperature on a Kelvin scale.
Now, if it's saying, it's not saying, like if it said today's temperature, there was a 20-degree increase from this morning to this afternoon. 20 degrees Fahrenheit. From when we woke up to when this afternoon, there's 20-degree temperature increase. That doesn't, so if this morning it was 70 degrees and this afternoon it's 70 degrees, how many degrees did it raise? 0. So that's different than 0 degrees. That's a 0-degree increase.
That means nothing.
That means nothing. That means the temperature did not raise. You see the difference? So being 0 degrees outside is different than the temperature increasing by 0 degrees. So that one may be that the temperature, and I'll pull it up, that the temperature went up 0 degrees. That may be what that one's talking about. I ain't gonna be wrong on that one.
Okay.
All right, salaries of college professors. So if a teacher made $0, she made nothing. So that means it's going to be ratio. All right, soft drink sizes, small, medium, and large. Okay, so we know it's qualitative, which means we can get rid of this one and this one. So which one's it gonna be?
Ordinal.
Ordinal, because we can place them in the same order. Because everybody knows that small is baby, large is when you're thirsty. We can put them all in the same order. Number of inches that a month it rains.
Maybe,
Okay, it's quantitative, which means we're only looking at this one, and this one.
okay, could be what kind of,
Okay,
kind of
so let's
scale?
talk about what 0 means. If it rained 0 inches, that means
No,
it
it didn't
didn't rain. So now we're looking at this one and this one.
it depends on what kind of gauge you have on it.
So what would you say?
I would say continuous.
Because you can buy, I mean, even cheap, you can buy a pretty accurate gauge. All right, let's look at another one. Oops. one says, what is the absolute error? So on my formula sheet, absolute error, what they claim it to be minus the true value. An email stated it was 210, but it was actually 220.5. So they claim that it was a 210, but in actuality, it was a 220.5. So if I go to my calculator, it's gonna be 210 minus 220.5. So it's gonna be a negative 10.5, which is gonna be that one. Y'all with me? Relative change. Again, this is on the formula sheet. It's new minus old over old times 100. Last year was this year is that, so what is my new?
Your new is 1435.
1435, my old is
1136.
1136. I'm dividing it by my old, which is
1136.
1136, and then I'm multiplying it by 100. So in my calculator, I do the same kind of thing. I'm going to do new minus old, get an answer, divide it by old, get an answer, and then whoop it. All of my answers are whole numbers. So the only one that's anywhere close is going to be the 26. Yay? All right, this is the one y'all kicked booty on and didn't remember. This is the histogram. I have my answer choices over there. We want to know between, this is ages 25 to 40. Use the histogram to answer the question. Let me figure out where the question is. The blood pressure readings, identify the midpoint of the third class. So 1, 2, this is the third class. What is the midpoint?
Midpoint 15, 0.15.
How did she get that?
The midpoint, that's it.
The midpoint means the middle. And where did the third one start? 120 to 130. And what's halfway between 120 and 130? Oh! Y'all with me?
I was Gotcha. I was too.
Midpoint. All right, let's look at another one. Line chart shows, and on your test, you'll have that little thing if you need it. Number of degrees in women in 1990. This is 1980, this is 2000, so this is 1990. We're only looking at women. Women are purple. So do you see that we have 1 box, 2 boxes, 3 boxes, 4 boxes, 5 full boxes, and a little something. 5 full boxes and a little something. What's my answer?
B.
So we have 1, 2, 3, 4, 5 boxes, and then a little something. Don't worry about why it's 556,500. It's 5 boxes and a little something. The final grade counts for 10%. So the midterm is 0.10, and he made a 74. Plus 15%, and he made a 91. Plus he made a 40% times 83, and then a 35% times 73, and I would type all of that into my calculator. Cool? All right. Exam scores for an exam in which most students did very well and a few students failed. Assume the scores go from 0 on the left to 100 on the right. Most students did well, a few people failed. What kind of skewness? Most students did well, a few people failed. That one is going to be left skewed. Cool? Find the median, standard deviation, and 5-number summary. This is 3 different questions on your exam.
Cool.
Okay? One question's gonna say median, one question's gonna say standard deviation, one question's gonna say 5-number summary. We're gonna do stat, edit, type in our numbers. Then we're gonna do, or maybe not. Let me type them in. So we're gonna do stat, edit, go to the top, clear it out, come over here, go to the top, clear it out. So 55, 40, 30, 55, 60, 70, 70, 70, and 44. So stat edit, then we're gonna do stat count 1 bar stats, because we only have 1 set of numbers, and I screwed that up. Go back in, and then enter, enter, enter. There's my first page of data, and then there's an arrow, so I go down to my second page of data. So, if we want the median, this is gonna be my median. If we want my standard deviation, this is gonna be my standard deviation. And if we want my 5-number summary, this is gonna be my 5-number summary. Cool? All right. The blood pressure of a group of 18-year-old women is a normal distribution. So we have a normal distribution with a mean of 120, a standard deviation of 12. What percent of these 18-year-old women have a blood pressure between 96 and 144? 96 is on this side, 144 is on this side, and we want to be between those two. So what is the screening that we do?
CDF.
Normal CDF. So we're going to do second bars. We're going to go to normal CDF. What is my lower?
96.
96. What is my upper?
144.
144. What is my mean?
120.
120, and my standard deviation is 12. All of my answers are in terms of percents, which means I need to whoop whoop that answer. Now, y'all, they said use the 68, 95, 99, 7 rule, and we said, oops, my bad, didn't do it. But I got my answer real close, didn't I? You with me? My answer's 95%, I got 95.44. So I didn't use the rule they told me to, but I got close enough. And that's why it's off, because the 95, 97, blah, blah, blah. But had I used the right rule, if I would have subtracted, 120 minus 12 is what? 1 something something. Somebody do 120 minus 12. 10, 108. And then minus 12 again. 96. Okay, so this is 2 jumps to the left. So 2 jumps to the left is going to be a what?
95.
95 cut in half.
45.
And then, so that's 47.5. Now, if we do plus 12, so 120 plus 12 is 132, and then plus 12 again is 144. Oh, y'all, this is a 2 jump to the left, 2 jump to the right.
Okay.
What's a 2 jump to the left and 2 jump to the right?
95.
A whole 95.
A whole 95.
So, I mean, we could have done it either way. All right, let's look at this one. Find the z-score. It's telling you to go to your formula sheet and use the z-score formula. But if I draw it, let's draw. We have a mean of 51, a standard deviation of 8, and our data value is 42. So I want to know how many jumps of 8 is it from here to here. Okay? So, what is my data? 42 minus 51 divided by 8. I go to my calculator. Is this going to be a positive or a negative number? Negative, because we are jumping to the left. So I am a little over 1 jump. So my z-score is going to be negative 1.125. So I am 1.125 jumps to the left of the mean. And that's all they want to know is how many jumps. What's my z-score? That's it. The mean is 63 with a standard deviation of 12. What is the standard deviation of the resulting distribution of sample means? Y'all are gonna look at this one and I've already seen it go. This one's my favorite one.
Easy, square
What
root.
is the standard deviation? What is the new standard deviation? How skinny am I gonna be? So the new deviation is the old deviation divided by how many people are in the group. What's my old deviation?
12.
How many people are in the group?
Now 9.
What's 12 divided by 3?
4.
Did we need this stinking number right here?
No.
It's there to piss you off, and it worked. The question says, we have a deviation, but I need another deviation. So I need a new deviation. And we've got a group. We got a group. So I'm putting people in a group, and I need to know the new deviation. We don't need the mean. Because what's the mean going to be if I'm in a single picture or a triple picture or a full picture?
The same.
The same. It's there to fool you. I just want to be skinnier.
And how you type that in your computer?
You're going to do 12 divided by the square root. The square root is right above the squared. So I hit second and then the squared button. The square root of 9. There's my answer. I'm going to go ahead and tell you the answer's going to be pretty. I'm going to go from a size 12 to a size 4 or a size 16 to a size 2. Hint, hint. Just saying. All right. We have a final exam. The final exam is a normal distribution with a mean of 73, a standard deviation of 7.73. We have a random sample. What is that telling me?
You're going to divide the square root.
That we have a group, so we have to do the new standard deviation, which means we have to divide by the square root of 24. We assume that they have a normal distribution. Our data point is 69, and it wants me to do less than 69. So, I'm going to go to my calculator. I'm going to do the normal CDF. What is my left?
Negative 9.
Negative 999. What is my right?
69.
69. What is my mean?
73.
What is my standard deviation?
7.73 divided by the square root of 24.
Divided by the square root of 24. And y'all, I type it in just like that. I take the old deviation divided by the square root of the new deviation. Whoop, there it is.
Now show me how you get to that again on the calculator.
Hold on, I will.
Thank you.
You see it? Now, these are in terms of percentages. So because they're in terms of percentages, what did I have to do to my answer? Whoop, whoop. So my answer is going to be the second one. So I did second bars, and I went down to number 2. Second bars, number 2. Second bars, normal CDF.
I got a question. How many places did you whoop?
Whoop, whoop, 2.
That makes it 0.6.
Rent is 0.562. Let's see, did I type something in wrong?
You got the L says 62% up here.
That's right.
Let's see. We've got negative 999, 69.
7.73.
Oh, 7.73. Calculator's only as good as the person who uses it.
That wasn't
No.
right. 73 was your
73
mean.
there. Second enter. Let me go up.
Yeah, just start.
Let's do delete. I'm thinking they used the table and they didn't use the thing, that's why we're off by a hair. But there's only gonna be one that's even close. So don't freak out if it's off just a little bit. They probably used the table and we're off because of rounding.
Yeah.
They used that 5 point whatever table. Yeah, so I wouldn't get, there's only gonna be one that's even in the ballpark. I wouldn't worry about it.
Okay.
All right, for this one, notice how I was nice enough to give you all the choices. Determine the probability that the sum is a 7. We do it on diagonals. So there is 1, 2, 3, 4, 5, 6 make me happy out of 36. What does 6 over 36 reduce to? 1/6. Everything is in terms of a fraction, which means my answer should be a fraction. Here's my expected value. So either it's going to rain or it's going to not rain. So it's going to be value times probability of this happening, and then value times probability of this happening. Now, when we did the one last time, raining was a good thing because we were a farmer. Here, we're doing a contracting thing,
That's not good.
so it's not a good thing. So, let's see. Oh, we're not even raining. Oh, yeah, we are. Okay, of a sale that promises a profit. Contractor is considering a sale that promises a profit with a probability of 0.7 or a loss. Okay, so either it's going to be a good thing or it's going to be a bad thing. So it's a good thing, we're going to make 38,000, and the probability of that happening is 0.7. If we lose 1,000, what are we going to put in? Negative 1,000, and the probability of that happening is 0.3. Because it's a loss. So in my calculator, it's going to be 38,000 times 0.7 plus negative 1,000 times 0.3. That would be your expected value. And they're going to have the answer there if you don't put the negative, because they know what you're going to screw up on. You dealt 2 cards, you shuffled them, so we have 2 cards, which means we're going to do 2 of them. The first card you pick is a jack. So what's the probability of getting a jack? How many jacks are there?
4.
4 jacks out of 52. Without replacement means you keep the first card. So how many's left?
51.
51. The second card is a king. So we kept a jack in our pocket. So how many kings are there?
4.
4. So in our calculator, we're going to do 4 out of 52 times 4 out of 51. 4 out of 52 times 4 out of 51. Notice how all my answers are in terms of decimals. So my answer is going to be C. This one is state the R and state the y equals AX plus B. So we're going to do stat edit, go to the top, clear, enter. 6, 8, 9, 8, 6, 15, 70, 81, 65, 82, 61, 90. So I did my stat edit, and this is 2 different questions on the test. I'm just trying to conserve time. So then I do stat calc linear regression. So to answer the first question, my R is going to be 0.7154. Strong, positive or negative? Weak, strong, or moderate?
Moderate.
Kind of moderate. And then for my equation, it's going to be y equals 2.416 x plus 53.898. Cool? All right. Next, this one is my actual fraction and then my rate. It tells me that I am doing accident Oops, thought I had my other thing. It tells me that I am doing accidents per vehicles. So I'm doing accidents over vehicles. So what is my actual accidents?
166.
What's my actual accidents? 166 was my actual vehicles. 255,019. And what's the rate that I'm trying to find?
X over 10,000.
X over 10,000. So I go to my calculator, I'm gonna do 166 times 10,000 divided by 255,019. And my answer, when in doubt, looks like it's C. Cool? This is that hardest one on the test. This is the one that you do the error, you type it in. Y'all with me? This is that one that we have, do you want me to do it?
Yes.
Sure. All right, so I'm gonna do stat edit. Stat edit, clear me out. Clear me out. And we'll go up and down. Tell me if I screw. I messed up again? No. Okay.
Well, that was fast. That's good, Danny.
That's good.
Okay, so I type it all in, I did my stat edit, and then I'm gonna do stat calc, 1 bar stats,
Right.
and I need to know my mean, I need to know my standard deviation, and I need to know how many bears there were. First thing I'm gonna do is I'm gonna calculate my margin of error.
Alright,
So, my error
2 times
is 2
5.
times my standard deviation over the size of my group. So 2 times 112.948 divided by the square root of 36. So it's going to be 2 times 112.948 divided by the square root of 36. So that is going to be my error.
Mhm.
So my error is 37.65.
Well, if you don't let us know at 36, will it come out right, or you?
It'll be in the, there's only gonna be one in the ballpark,
Okay.
yeah. So, my mean was 183.58. So 183.58 plus my error and 183.58 minus my error. So,
The error is
183.58 plus the 37.68, 183.58 minus the 37.68. So my confidence interval is always the smallest to the largest. It's not that bad.
No, you do it. Yeah.
I'm not stressed. All right. This one says estimate the sample size. Your sample size is your n. So it's 2 times standard deviation over error squared. So 2 times my standard deviation is 1.3. My error is 0.06. And then I'm going to square it. So it's going to be 2 times 1.3, get an answer, divided by 0.06, get an answer. And then raise it to the second power, get an answer. And because we're talking about people, can't be a half of a person.
Right.
All right, this is the conditional probability, meaning we're not looking at everybody, we're looking at only certain people. So probability over total, but we're not looking at everybody. So for the first one, we are only looking at the passive approach. So passive, how many passive people were there?
300.
300. And of those passive people, we want to know how many sold using the passive approach. 220. Now, for 52, I want to know how many did not sell using